Recently, we hooked up vital systems in the plane and gave them an impromptu test.
I think I just turned my plane on for the first time.
This time on Ryan Flies, we continue the harness installation within the airplane, mount LRUs, tidy things up, and a whole lot more. Stay tuned. There's a lot that needs to be done, but I think I have a pretty good idea of where I need to go. Before I get all my LRUs mounted and plugged in, I want to make sure that my power pins are in the correct position, and same with my ground pins. Other mispinned items would be frustrating, but they wouldn't be tragic. So the best way to test those pins, I believe, is to first get my grounding block sorted, and same with my power bus. This means that when I'm testing the pin on the connector side, all I have to do is connect the ground to anywhere that's grounded, or the power to anywhere on the power bus, and I should get an audible tone from my multimeter. If I don't have those set up, I'm stuck trying to find the correct wire out of this bundle and connect that to one end of the multimeter and the pin of the connector I'm testing to the other end of the multimeter to get that audible tone. That's a little bit tougher. So I'm going to make it a little easier on myself and get these two ends sorted so that I can go ahead and test the connector pin by pin. They skipped I on the lettering on this thing. I'm guessing so you didn't confuse it with a 1 or a lowercase L, but they skipped I. And of course that's the first one that I picked, was I. I think my problems are worse than that. I think what it doesn't click in like all the other connectors I've used. I think what you're supposed to do is actually put your wire here through this thing, then crimp your connector, and then it won't pull out the other way. That's a pain, you know, and I thought it would just click in like everything else I've been dealing with. I mean, what do you expect for a couple $100 frickin' dollars? $15 in all fairness. But the part attached to the plane that I'm sort of mentally grouping with this is nearly $150, and creative rounding will get you to a couple $100, I suppose. Well, I'm glad I only did 4. So these all need to be cut off. Gosh dang it, man. I think honestly at this point I would have preferred the forest of tabs I have on the front side, on both sides, like I've seen a lot of people do. I'm not overly impressed with this whole quick connect grounding block thing. I thought it would be simple and fun. It's neither. So we'll try to strip, and it goes through. In this case, P. Then my connector goes on. Now we crimp. And I guess that's essentially how it works. And then in this case, it just plugs on. Well, before I bitch and moan about this anymore, and before I get too far and wind up having to cut more connectors off, I'm going to give this a test. So the G5 should theoretically here be grounded once I plug this in, except the connector just kind of falls out on you. This thing sucks, man. Okay, it's plugged in. Let's go test it over there. Okay. On my multimeter, I have expertly taped a female and a male connector depending on which type of connector I'm working with. So female terminal, male terminal. We'll go ahead and get the plug off of here. Now I've got females here, so I'll use my male here, and in pin 9, should be able to plug this in, and I should get a sound if I ground this to the plane, because the ground is the plane. And as we see, we're working. A tip here while we got everything hooked up, go ahead and switch your multimeter over and test the resistance of the connection. A good, well-connected ground should have 0.5 ohms or less. That's what you're going to want to see when you test all of these. So that's what I would like to do for not only the ground on each connector, but the power as well. Those are the two critical ones. Again, a misplaced signal wire, yeah, you know, I could get a signal failure, or a CAN bus wire misplaced, I get a CAN bus failure. But I'm not going to fry a box. With the power and ground. Now, theoretically, if I just got those two switched, I think most of these are wired to prevent any damage. However, if I wound up getting the power sent to a signal, I could fry some of the more delicate pieces there. All right, I'm excited about the testing. I'm less excited about that ground block. So I'm actually gonna try the power version of this, and I will see if I can get continuity from the bus over there over to here by plugging in the power wire that would go to the fuse. I'm using number 3 here. This gets plugged into number 18. Just clicked in. Ah, shit, I forgot my seal on it. I have these little seals. They're supposed to go in there. I should be able to simply have one end here anywhere on that power bus and probe the other end into the power cord. And power should be on pin 7. Oh no. There goes my stool. Pin 7. This one I'm not getting a tone on. And that bums me out. Oh, I know what it is. I gotta have a fuse in there. There it is. Alright. Power is correct. Ground is correct. Moving forward, I know that my testing procedure works. I gotta have a fuse in there. But then all I have to do is I can test all my connectors at once. This is great. I'm gonna go ahead and just clip all these off. So that they're the same length. Then I'm gonna go ahead and lace them through this horrible little connector that I'm no longer fond of. Then I'll do my stripping and crimping. Then I should be able to plug this in. I will have to add some later on, but that shouldn't be a problem. This way I get everything grounded, and then I can test my grounds. All right. I'm also going to do the same thing now that I know in theory this works with the fuse panel. So I will get all of my wires there clipped to the correct length, and I will get my ends, my terminals added on. And then in this case, I actually need to make an additional step of inserting the correct amperage of fuse, which is all in my wiring diagram, so that shouldn't be a problem. And I'll plug all those in, and then I can move along and I can test all these connectors. That's something that I absolutely must do before I turn this on, and realistically should do it before I get to a spot where it's no longer easy to test them, meaning I've cluttered this whole area with LRUs and I've plugged in most of the connectors. After some relatively frustrating back and forth on connectors and wires, I think it's time to get some meaningful progress done. I'm going to try and mount the GSU. So let's see what that entails. The GSU is sort of the brains of a lot of the operation here. It is going to take in airspeed via the pitot tube, static lines, angle of attack, and it's also going to take the orientation of the aircraft. Therefore, it's incredibly important that it be mounted to an area that's sturdy, hopefully vibration free, or as vibration free as you can get it, level and straight. I have previously taken some level measurements to make sure that the plane still sits level after the wheels and tires. Luckily, it's pretty spot on. And so I've gone ahead and put a line up here as to what known level is. It's important to note that level on this sub panel is not necessarily what's level on this bracket right below it. That sits at a bit of an angle. So when you see me installing this, it may look like it's a little crooked. It's in fact not. These brackets here that sit just below where the GSU is going are at a bit of an angle on either side. Another important note here, this piece flexes a lot right now. Now, previously in the build, I went ahead and clecoed on the forward skin to make sure that there was not too much deflection in this piece. I know it's popular among a lot of builders to go ahead and put a doubler here. Personally, I don't know that the doubler does a whole lot. In fact, the doubler, in my opinion, does very, very little compared to having all of these rivets bolted into the skin, which is bolted in to the rest of the structure. In fact, that's the theory behind the van's engineering process, is that the strength comes from the skin. And indeed, when the skin is on this, there is almost zero movement allowed in this sub panel, especially in this top corner area where I've got the GSU mounted. So I'm refraining from a doubler here. I think there's plenty of strength in the sub panel enough, especially near all these other rivets. All right, enough hemming and hawing. Let's go ahead and poke some holes in this thing. can't quite get to that last rivet. So I'm gonna have to shoot it, which I'm contemplating doing, but it's like 7 o'clock in the morning. It's 4th of July. I'm wondering how much patience my neighbors have with me. I guess I'll edit some video for a bit. So the GSU was in, and I had it bolted in and all that, hunky-dory, but I've removed it. And the reason is, I've got to set some more rivets for some more nut plates for the next box to be installed on this, and I don't want to be riveting on the sub panel with the GSU installed. It's a delicate piece of equipment. There's no reason to put it through that sort of vibration. So with the remote radio removed for some better access, I'm now going to drill some holes and once again install nut plates for the engine box, if you will. You can actually watch as I drill this thing, the template slowly get more and more off kilter. And that's a bummer, because when I went to go put this box in, I noticed that it was slightly crooked. I was able to mostly straighten out the box by widening up the holes in the sub panel and then placing the nut plates where the box would be straight. It's not ideal, but lesson learned about adding enough tape to your templates before drilling. A few of you might be wondering why I'm fussing with all these nut plates when I literally just had the thing bolted to the sub panel. The idea is serviceability. I will not be able to easily get to where those nuts were once I have the forward skin on and everything buttoned up. If I ever needed to pull the GSU or any one of these other items, I would have to somehow try to fish nuts back there and hold them along with a wrench to tighten everything down. With nut plates, I can simply remove one of my GDUs and use a socket wrench or a hex driver to unbolt these items and then bolt them back in without ever having to get back behind the sub panel. The boxes are in. They're looking good, I think. Some of them a little cleaner than others. There's another thing we're gonna do while I'm addressing this general area, and it really relates to this box, the GAD 27. I don't like the wire routing, but I've got a pretty cool idea on how I can improve it fairly swiftly. And this is where things get relatively uninteresting, to be honest. The footage, spotty. I was in the zone. I was just moving through it. And the subject matter is a little dreary at times. I'm just running wires. I'm running wires mostly related to the switches on the panel. I have to run power wires to the switches and then to the devices. And then I have to run ground wires from the ground to the devices. And I have to label all these wires. And for the most part, it's fairly uninteresting. I will say this, it's allowed me to find some deficiencies in my wiring diagram. Most of my wiring diagram was related to the G3X system, but there are a lot of systems outside of the Garmin boxes. For example, pitot heat. Pitot heat requires a power line, it requires ground, it requires a switch, it requires all these to be hooked up, it requires a connector between the fuselage and the plane. And this should absolutely be on a wiring diagram, but it's not on mine. Why? Well, again, I was mainly focused on the G3X system, and this fell a little outside of that because it's never plugging into a box or an LRU. Does that mean I forgot about pitot heat? No, certainly not. There's a switch for it, there's a place for it, and it's been in the back of my mind, but pushed way back there because I've been dealing with the more complicated and, to me, a little more fun wiring projects this entire time. There are a lot more things like pitot heat that aren't on my wiring diagram and therefore haven't really been addressed yet. For example, fuel boost pump. There are also some items that I found that there's some mistakes in my wiring diagram. For example, flaps. I have 2 inputs on my Garmin LRU for flaps, and so I figured I would utilize that for a co-pilot and a pilot flap control from the control sticks. However, I totally neglected the fact that I have flaps sitting on my panel as well. It has 2 flap inputs. I'm like, 2 inputs, that's great. I got 2 control sticks, and that's how I wired it. And I sort of omitted the fact that I have a toggle switch on the panel as well. See? Told you. So I've had to do some splicing and rewiring, and then making sure to alter my wiring diagram so I have this all noted for the future. Why am I telling you all this? Well, A, I needed some voiceover to go with all this crappy footage, and B, I wanted to explain that all of this takes a huge amount of time, and I'm going to somewhat fast forward through it all for you, but it's there, and it's hours and hours of running wires through already fashioned bundles and creating labels and trying to button it all down so that things work once I finally turn this on. I'm doing a lot here, getting quite a bit done. And a lot of it's just tidying up all this wire and slowly moving it back towards the back of the plane, the harness that is. You saw I managed to get the flux capacitor out. That's going to help routing wire around here. Not only that, there was that funky bend in the tube from a while back that I didn't like, and I mentioned I was going to redo it, so I'll probably redo it. I managed to get the plug-in for that same piece of equipment much quicker. If you remember the last time, I struggled a little. Once you do it correctly, they're actually incredibly easy. I love those things. I have another power cable to run, thick gauge for the pitot heat. Not only fix the fuel pump and the cable so I can get that back in and plugged in and all hooked up. That'll allow me to store as many cables around here as I can. I'm going to get a grip of this through. We're going to put a connector on and hook the flaps and the flap sensor up. Then we're going to route it into where the battery backup's going to go. I'm going to mount the battery backup, get the connector placed on that. Then we've got pieces that continue aft. We're going to hook up the And on that note, we close out another one. And honestly, I couldn't be happier with my giant freaking list of things to do, sitting in my plane, slowly getting it squared away, only weeks away from turning this all on and testing it out. I hope you all are as eager as I am to hit that switch for real and are clearing your calendars. Until then, I leave you with this. I dropped a rivet, and you gotta see how it landed. Just a reminder, you're going to want to make sure you're subscribed if you want to see more quality content like this in the future.